Okay, so good morning. Today I'm going to talk about local HB-spline projectors via restricted hierarchical spline fitting, and this is a joint work with Bert, Jüttler and Angelos Mantzaflaris. So I would like to introduce immediately our work. Our goal here is being able to perform an approximation of a given function f adaptively in terms of hierarchical splines. So we are going to get an approximation of f expressed as a sum of some coefficient ci times the basis function beta I. And this is a list of our goals. So we want to perform local refinement via hierarchical splines, as I just mentioned. Then we want to have general QA schemes for THB splines and HB splines respectively. Moreover, we want to have spline projectors. So if we project the spline S, we will get back the same spline S. And moreover, we want to have efficient schemes with a low computational complexity and accurate scheme with optimal approximation power. And let me just mention there has already been some previous work about QI schemes for hierarchical splines, namely the work from Kraft, which focuses on the HB case, and more recently the work from Speleers and Manni, which focuses on the THB case. So I would like to move on now to our approach, to our structure here. So we have two projectors, P beta for the HB case and P tau for the THB case, which are expressed as a sum over the levels, L, and as a sum over the active basis function on each level. And the question here is, how do we compute the coefficient functionals mu I and nu I, which appear in the previous expression? And we chose to perform a local L2 projection with respect to some proper subdomain delta, and we were able to identify some conditions on delta which allow us to conclude that we have a THB spline projector or an HB spline projector. And here you can see two pictures. This is mesh with two levels. The red color denotes the subdomain delta, which I colored in red, and the orange color is basically the support of the basis function beta. On the left you have the THB case, so we have a condition: if the support of beta is contained in delta, then we can conclude that we have a THB spline projector. On the other end, for the HB case, the condition is a bit different, so we need to have the sub star of beta. If this support is contained in delta, then we have an HB spline projector. And substar is basically the extended support of beta, so you have to consider every basis function which completely contains the support of beta. Moreover, you see we have a point grid in blue, and we are able to show that with a proper choice of this grid that we use to perform our L2 projection, local L2 projection, we have an efficient scheme with a complexity of OP to the D flops per spline coefficient and O of 1 evaluation of F. And moreover, we can also show that we have optimal approximation power. So let's move to an example now to check the accuracy of our approach. Here we approximate the function F over a domain which is just a square. And you can see here that we have a comparison between our method using HB and THB splines, a global fitting strategy with hierarchical splines, and the case of uniform refinement when tensor product splines are used. And you can see that we have basically the same rate of convergence as global fitting with hierarchical splines, and we also have a comparable accuracy with a lower number of degrees of freedom if compared with the case of tensor product splines. So now let me conclude and sum up. So we have a local refinement strategy. This follows immediately from the use of THB splines or HB splines. We have a general QI schemes for THB spline and HB splines. Again, they present the same structure, and this is a sort of unifying framework for quasi-interpolation in hierarchical spline spaces. Moreover, we have spline projectors. This is proven. We have efficient schemes with OP to the D flops and O of 1 evaluation per DOF. And we have accurate schemes with optimal approximation power. We have evaluated that experimentally, and we have also carried out a comparison, a detailed comparison with another scheme presented in literature namely the one from Speleers and Manni. And with this I would like to conclude and thank you for your attention.